Welcome class. We're still on the topic vectors and vector addition. On the part 1 and part 2 of this video, I explain what a scalar is and what a vector is also. And I told you that scalars are those quantities which are described by their size or magnitude only. I let you know that scalars have no what? Direction. Scalars have no direction. And we are talking about scalar. We are talking about examples like what? Temperature. We are talking about examples like what? Speed. We are talking about distance. We are talking about time. We are talking about what? Mass, and so on and so forth. So these and others are examples of scalar. So on the other hand, vector quantities are those quantities which can be described by their size or magnitude, and also what? By their what? Direction. In vector, we don't only look at size and magnitude, we also consider their what? Direction. An example of vector quantities are what? Force, velocity, acceleration, pressure, displacement, and so on and so forth. So from there, I moved on to what? Vector addition. I'm trying to summarize the last video. Vector addition. When you come to scalar, we can easily add up scalar quantities. 40 gram plus 50 gram, or 4 kilogram plus 5 kilogram gives us what? 9 kilogram. These are vector what? Quantities and vector addition. Very easy. 3 meter minus 2 meter give us what? 1 meter. These are vector what? Quantities. These are scalar quantities, sorry. Scalar quantities. You can easily be added. 4 kg plus 5 kg give us 9 kg. 3 meter minus 2 meter give us what? 1 meter. These are scalar quantity. But in vector addition, when it comes to vector addition takes into consideration not only the magnitude. Vector addition takes into consideration not only what? Magnitude, but the direction of the vectors matter. You get what I'm saying? So the method of calculation, that means in terms of what? Vector addition, depends on whether the vectors are acting in a straight line. So we have to look at, is it acting on a straight line or at an angle to each other? So I'm going to look at some typical examples in vector addition. The first one, I'll call it A, is what? A. So in this A, we look at what? Two parallel forces acting in the same direction. What do I mean? We have a box. Two men are pushing it this direction. The first man is applying a force of 100 Newton. The second man is applying a force of what? Let's say 80 Newton. Now look at it. This is a box. Two men are applying a force through this direction, pushing it toward this direction. The first man is pushing with a force of 100 Newton. The second man is pushing with the same direction. You can see the arrow. The second man is pushing with a force of what? 80 Newton. So what is the total force acting on this box? So to get total force, which is the resultant force, so we can see that the resultant force on this box equals what? 100 Newton plus what? 80 Newton, giving us what? 180 what? Newton. So the resultant force acting on this box is what 180 newton. So what does it mean? When two forces acting parallel along the same direction, when two forces acting parallel along the same direction, so you just have to get the resultant force, which is the one single force that's equivalent to the two forces acting together, just the addition of the what? Two vectors. We just give you the summation. When they move what? When the forces what are moved towards the same what direction, the resultant force equals what? The addition of the two what? Of the two forces. What if they are acting in opposite direction? What if acting in what if they are acting in what? Opposite. Opposite direction. What do I mean? We have a force, the force of 80 newton is this way, and the force of 100 newton is this way. Can we relate this to any practical thing we know? Yes. We have a box at the middle. A man is standing here, another man is standing here. This man is pushing this box toward this direction, applying a force of 100 newton. This man is here pushing it toward the direction, applying a force of 80 newton. You already know what the answer will be. Which direction will the box move? It will move towards the direction of 100, because this 100 is greater than this 80. So looking at it and relating it to normal happenings, okay, we want to open a door, one is at the other side of the door, and that man is at the other side of the door, they are pushing the door. You know, the one that apply the highest force is the one that what either open or close the door. Are you getting me? So if the one that's opening it have the higher force, that means the door will open. If the one closing the door have the higher, apply the higher force, the highest force, the door will what? Close. That means if two forces are acting in opposite direction, the resultant force is just what? The 100 newton minus 80 newton, which is equals to what? 20 what? Newton. I hope you understand this with the examples I gave. Yes, if you don't, please go through it again. I'm trying to summarize scale if I move to what? Component of forces. Vertical component and horizontal component. So, and how to resolve them. So now, what if we have another scenario? These are forces acting on a straight line, one in the same direction, the other in opposite what? Direction. Now, what if we now move to B? When two forces, we now move to B. Here, two forces acting perpendicular, perpendicularly, perpendicularly, and we hear perpendicular, we're talking about what? At right angle. And what does it mean to be at right angle? That means 90 degree. 90 degree to each other. Now, what does it mean? A force acting this way, and that force is acting this way, and then this side means 90 degrees from each other. So, we have a situation like this. How could such a situation be tackled? Here we have our words. Here's our F1. Here's our what? F what? 2. So the resultant of these two forces now, the result of these two forces is the diagonal of the rectangle. That is, it should be a rectangle that is in a situation when f1 and f2 are not equal to each other, or square, diagonal of the square when f1 and f2 equals to what? Each other. What did I mean? Here, let's take this scenario that f1 and f2 are not equal. Here, let's take it that f1 and f2 are equal. f1, f2. Then, now the diagonal, if f1 and f2 are equal, here will now look like a square. Here will now be a square. If f1 and f2 are not equal, what you have here is what? To form a shape of a what? This will form a shape of what? Rectangle, while this will form the shape of a what? Of a square. Here is the resultant. Here the resultant. You get it? So here now will be the what? Theta. Yes, our theta to the horizontal. So two forces acting perpendicular to each other. The resultant is the diagonal. You get it? Diagonal or the rectangle. And diagonal start between what? F1 and F2. It's between F1 and F2. We pick as what? The diagonal. It's not this way. It's this way between F1 and what? F2. It's where the diagonal what? Come out what? Come out from. So now looking at it, what can we see? You know that f1 here, if here's f1 in um talking about what? Triangle, opposite sides are equal. So if here is f1, here also is f1. So if here is f1, here is f1, here is 90 degree, here is f2, what comes to our mind is what? Pythagoras. Pythagoras. And Pythagoras rule, you can see that r square is equals to what? f1 square plus what? f2 square. So our resultant is equal to what? The square root of what? f1 square plus what? f2 square. So in trying to get this angle now, theta, it tries to get the theta, that is the direction to the horizontal at which the horizontal act is at angle theta, and is found using what? Trigonometrical formula as shown. Now, if here is theta, we know this as our f1, we know this as our f2. Now, tan theta is what? Opposite over what? Adjacent. And our opposite f1 here, that means here also is f1. Rectangle, opposite are equal. Same with a square. So what goes here? This formula also works for this also. So our opposite is f1, f1, and our what? Adjacent is what? F what? F2. So in getting your theta now, our theta, all we have to do is what? I'll get what? The tan inverse. The tan inverse F1 and the magnitude of an angle, the FA. F. So there is that when two forces are acting what? Are acting perpendicularly what? To each what? To each other. So we're going to see another scenario when the angle between the two acting forces is acute. When the angle is acute, that means the angle is between 0 and 90, or what? Obtuse. That is between what? 90 and what? Greater than 90, and between 90 and 180. In such scenario, what are we, what should we be expecting? In such scenario, what should we be expecting? So we have C here. So in that C, angle between the two acting forces acting forces is acute. Is acute. That is what? Between what? 0 degree and what? 90 degree. Or obtuse. We're talking about obtuse. We're talking about when the angle is what? Between what? 90 degree and what? 180 degree. Let's look at these scenarios and see how we can attack questions where it comes to either of these. So if it is acute, we are looking at something like this. When here is an angle, which is an acute angle. Let me, okay, it's an acute angle. Then here's our F1. Let here be our F2. You get it? Now, if it is obtuse, greater than 90, sorry. So let me call here F3, F4. Yes, okay, let me call here theta 1, here theta 2. So theta 1 is an acute angle, while our theta 2 is what? An obtuse angle. So in these scenarios, how are we going to tackle it? Now, assuming that F1 and F2 at 50, let's assume here is 55 degree. You know that 55 degree is less than 90 and greater than 0. So it's acute. And let's take a angle between F3 and F4 to be what? 135 degree. Let's take the what? 135 what? Degree. Hope you are with us. You are up here with me. So to find the resultant for each angle, a parallelogram is drawn. How do we get the parallelogram? In parallelogram, opposite sides are equal, and opposite angles are also what? Equal. All you have to, if here is F2, do you see the parallelogram? This, this goes up, this goes up. Same thing here. So a parallelogram is drawn. You can see the parallelogram here. If here is 55 degree, here also is 55 degree. If here is 135 degree, here also is what? 135 degree. And you know, this is a quadrilateral. Quadrilateral, I mean what? Quadrilateral are shaped with what? 4 sides. Quadrilateral is shaped with 4 sides. So, and quadrilateral have total angle of what? 360 degree. Quadrilateral have total angle of what? 360 degree. N minus 2 times 180. N minus 2 times 180. Why n is the number of sides? How many sides do you have here? 1, 2, 3, 4. 1, 2, 3, 4. Put 4 here. 4 minus 2 will give you what? 2. 4 minus 2 will give you 2 times 180. So 2 times 180 degree equals to 360 degree. So this is formula to find what? To get total angle of any what? Polygon. Of any polygon. And quadrilateral is a polygon of what? Of 4 sides. Quadrilateral are polygons of 4 sides. Example of quadrilateral, we have parallelogram is a quadrilateral, rectangle is a quadrilateral, square, we have your rhombus, you have your kite, you have your trapezium, and so on and so forth. So talking about parallelogram, it's a quadrilateral. And what can we say about parallelogram? Well, we can say that the opposite sides are equal. So if here is F1, here also is F1. If here is F2, here also is F2. Same with this. If here is F3, there is F3. If here is F4, here also is what? F4. What else can we say about parallelogram? The opposite sides are parallel. This is parallel to this side. Here is parallel to this side. Here is parallel to this side. There is parallel also to this side. What else can you say about parallelogram? The opposite angles are equal. So if here is 55, here is 55. Now knowing that means these two angles also will be equal. One thing you should know that if it's parallelogram, this plus this should be 180. So if here is 55, that means 180 minus 55 will give us 125. Here to what? 125. Just an easier way. Instead of adding 110, 55 plus 55, 110, 360 minus 110 give you 250. 250 divided by 2, 125, 125. Just know that here plus here will give us 180. So if here is 135, 180 minus 135 give you what? 45. By the time you do what? 135 plus 45 degree will give you what? 180. So you have 180 here, you have 180 here, you have 180 here, you have 180 here. 180 plus 180 is 360. Hope you are with me. Just pay attention in my class. You will surely get it. You will surely get it. We move together. We move together. So now having gotten to this point, the resultant R of the forces F1 and F2, the resultant R, F1 and F2 is the diagonal of the parallelogram. It is diagonal of the what? Parallelogram. Let me call here A, B, C, D. The diagonal of the parallelogram. No, the diagonal is drawn from the point of intersection of forces what? F1 and F2. The first intersection of F1 and F2 is here. So our parallelogram, our diagonal will come from where? Will come this way. This is our what? Resultant. Same with this. Intersection of F3 and F4 is what? Around here. Around there. So if we have done this, that means to get our angle to F2, call here, we call it alpha. The full length from here to here is 55 degrees, but only that means alpha is less than what? 55. Same here, if I have to get here, call here what? Alpha. So now, if I have to draw this out now, what am I going to have? We'll be having something like this. Here was 125, right? Yes, here's 125. Here's our F2. Here's our F1. Because opposite sides are equal. Then here's our what? Resultant. And if you should draw that out also, if you have something similar, you have something like this. Here's F4. Here's F3. Here 133 was 45. Here's 45 degree. There's our resultant. There's our resultant. So that's how we resolve. And to get R now, so here is the alpha here. Alpha will be here. Alpha also will be here. So we're going to use sine rule to get our R. We will use sine rule, and to get the angle, you can use sine. No, to get R, we use cosine rule. Yes, use cosine rule to get this. Then we'll now move to sine rule to get this other angle. Or you can just say this angle plus this. Okay. Okay, we don't know here. Okay, we use sine rule to get here, and after getting here, we'll use cosine rule to get our resultant. Yes, we'll now use sine rule to get our alpha, our angle, and that will be the point we'll be moving to what next. So see on addition, vector addition. Very soon I'm going into components of vector. So now let's assume a scenario where we have our F1 is let's assume it's 10 Newton, and our F2 let's assume it's 12 Newton, and so we have something like this, and here's our resultant. Here, okay, sorry. Let's assume we have something like this, and this angle here is 125 degree, just the one we did there. Then it's our alpha. Then here's our F1, that is what, 10 Newton, and F2, that is what, 12 what Newton. Now we should get what, the resultant. Now our cosine rule says what, r square equals what, a square plus b square minus 2ab cos theta. Cos theta, are you getting me? Yeah, our theta is what, 125 degree. Our a and b are what, our what, f1 and what, and f2. So I'll see here r square equals what, your f1 square plus f2 square minus 2 times f1 times f2 cos theta. Cos theta. Or if here is a and here is c and here is d, so to be cos d, because the angle at what, the angle at d. So let's go ahead. R square, what's our f1? Our f1 is 10. 10 square. Our f2 is what, 12. You can see it, f2 is 12. It's up here, 12 square minus 2 times f1 is 10 times f2 is 12 cos what, 125 degree. 125 degree. So what are we getting from here? R square give us what, 100. Square of 12 is 144 minus this is 120 times this is 240 is 240 cos 125. Cos 125 is negative of what, cos 55. So if you go to a formula table, cos 55 will give you approximately minus what, 0.5736. Yeah, so cos 55 is 0.5736. And cosine 125 falls in the second quadrant. I'll still touch that one in maths. Falls in the second quadrant. And in the second quadrant, only sine is positive. Cosine and tangent both are negative. So when you proceed with this, you have r squared giving you what? 100 plus 144 give you 244. Minus times minus will give us what? Addition. 240 multiplied by 0.5736 will give you around 137.66. So now to get our r, we find the square root of both sides, which is square root of, and the sum here will give you what? Sum here will give you 0.66. 1 take away 1, 783. 381.36. So 2.36, yes. Yes. So we get the square root of 381.66. The square root of 381.66 is approximately what? 19.53 Newton. So no, it's false, so our answer will be in Newton. So now we have gotten the resultants. So the direction, the direction of the resultant vector, this resultant vector, which is 19.53, what the direction of the vector is the angle alpha. Are you getting me? And the angle that it forms with F2 vector. Are you getting me? So what angle does this resultant, which we have as 19.53, form with this F2, which is 12 Newton? To get it now, this is where the sine rule comes in. What is sine rule? The formula for sine rule says what? Sine A over A equals what? Sine B over what? B. Initially, why can't we use sine rule? You need to know. Initially, we have this angle, but we don't have this opposite line. We have this line, this force, but angle opposite it, we don't have it. We have this force, but angle opposite it, we don't have it. Whenever you're present with this kind of scenario, you use cosine rule. But now we know this angle and we have gotten this angle as 19.53. Are you getting me? 19.53. So we have gotten an angle and the subsequent opposite force. Are you getting me? And whenever you have a triangle, you know the opposite side and you know the angle opposite it. One of them is complete. In that scenario, you can use cosine rule. So this one that is complete, the angle is 130, 125. So sine 125, and the angle, like the first opposite it is what? 19.53 equals to, this is the man we are looking for now, this alpha. And the first opposite is alpha is 10. So sine alpha, angle comes first, sine alpha over what? Over 10. So we're trying to get the angle alpha. Trying to get the angle what? Alpha. So proceeding from here, using what? Our knowledge of what? Mass is it now as sin C over C. So just have it in mind. So we're looking for sine alpha. Making sine alpha when you cross multiply, you have 19.53 sine alpha equals 10 what? Sine what? 125. So sine alpha equals to 10 sine 125 over what? 19.53. So now looking for what? Sine inverse. Sine inverse of what? Sorry. Our alpha now is sine inverse. Sine inverse of what? 10 sine 125 over 19.53. So when you go for the sine inverse of that, to be giving you what? Our alpha to be what? 24.8 degree. Give it 24.8 what degree. So if you recall, okay, this was like this before. Yes. So that's trying that here what 55 recall. Here what 55. The full is 55 degree, right? So if here is 24.8, that means this other side is what? Will be, I think it's 30.2, I mean 30.2. So that is how it goes. So the magnitude and direction of resultant is, the magnitude of the resultant is 19.53 Newton, and is what is at 24.8 degree to what? 12 Newton force, and at what? 30.2 degree at what? 10 to the what? 10 Newton. If here is 10, here also is 10. So the 10 Newton force is what? 30.2, which here and here are what? Equal. Are you getting me? 30.2 to the 10 Newton force. So that is for this scenario. What if we pick the other scenario, still using what? 10 Newton and 12 Newton as our F1 and F2, and we have it like this. The other scenario we have something like this, right? If you remember, let's say be our F1 that is, let me put F2 here, that is 12 Newton, and here be my F1 that is 10 watt Newton. Remember the angle there was 135 that gave us here as 45 degree, and here being our what? Here being our what? Resultant. So here now going to be our what? Alpha. When we encounter something like this, and here is our A, let me say here is G, and here is H. That means you are going to change it to what? H. Hope you are with me. We change it to H. Here we still remain our 10 Newton plus 12 Newton. This is the resultant. Here is minus 2 F1 F2 cos. Here we'll be having what here? I'm going to what? 45 degree. and cos 45. Cos 45, if you are, yes, that's 45 degree, and cos 45 is that should be 0.7071. Yes, that should be it. That is, sorry, let me verify. 1 root of 2 45, cos 45 is 1 over root 2. 1 over root 2, that is root 2 over 2. Root 2 over 2, which is, it should be 0.7071. Okay, so here should be, okay, since I'm not that sure, let me use the root 2 over 2. Root 2 over 2, yes, which will be here. So here, okay, let me erase from here. Root 2 over root 2 is, this is it now, sorry. Root 2 is 1.414 times 0.5. Yes, 0.7071. I'm correct. I'm correct. I'm correct. 0.7071. Yeah. Yes, 0.7071. Yes, 45. You will ask, why didn't I put minus here as the previous one? It isn't because 45 first thing was first quadrant, and in first quadrant, both sine, cosine, and tangent are what? Positive. So by the time you simplify this, 100 plus this will give us what? 244. 240 times 0.7071, you'll be having around 169.70 approximately, yes, and this will give you 74.29. So here our r now is the square root of what? 74.29, which will give what? 8.62 watts Newton. 8.62 Newton. Now you've gotten the resultant. Now getting getting our alpha now, which is the angle the resultant makes with 12 Newton, or the angle the resultant makes with what? 10 Newton. Now, still using that formula, sine A, here will be 145, here will be 45 now. Here will be 45. 45 here is what? 8.62. Then sine alpha over 10. Sine 145 is written as cos 145. Recall that sine theta equals to what? Cos 90 minus theta, and cos theta equals sine 90 minus what? Theta, under your trigonometric ratio. So still moving. Okay. Now can see from here that sine alpha multiplied by 8.62 is same as 10 sine 45. So here now sine alpha equals to 10 sine 45 over what? 8.62 over 8.62. And here, so sine inverse of what? 10 sine 45 over what? 8.62 is our what? Alpha. And when you impute this in your calculator, you'll be having approximately 55.6 55.12 degree. You have 55.12 degree. So this is our resultant. Recall that this is like this. This like this. Here is our 10 Newton. Here is same as 12 Newton, right? So our resultant, we have gotten our resultant to be what? 8.62 what? Newton. So the magnitude and direction of the resultant of the vector F1, which is 10 Newton, and vector 12 Newton F2 is what? 8.62. At this 8.62 is at 55.12 degree to the what? To 12 Newton force. Recall, if here is 45, the full angle here is 135, right? So if here is already what? 55.12 to 10 Newton force is going to be 135 minus 55.12, which will give you what? 70. This 72 should be 79.88. I'm sure of that. Just to confirm. 97, yeah. Just to confirm. So, seeing how to, if it's 79.8, I'm here 79.88, and that's how it goes. So from this point now, I'll be looking at in a situation where we have what? More than what? Two forces acting on a point. When it's more than two forces acting on a point, that will be made available in the next video. Please watch out for the next video. And if you haven't subscribed, please do wait to subscribe and call your friends, call your classmates, call your colleagues, those that have challenge on that vectors and vector addition, to go through this. And you guys can go through it well. If you understand it, get one or two persons, or get one or two persons to what? To coach or to teach, so that what you what know it and understand it what better. We are working together. Let's work together to grow this channel. Let's work together as one. Let's love one another. Introduce people to this channel so that we all will grow together. If you have any area of support, you can check my channel description. Anything is will be appreciated. Please, for now, I'm going to stop here. Watch out for the next part. I don't want to make the video very long. Where we'll discuss what when we have more than two forces acting on a point, and after this, after we are through with that, we'll look at some examples before we'll now look at vector resolution. Then after vector resolution, I will now move to what? The unit vectors, scalar products, vector products, and so on and so forth. I will break everything down, and for you to know that physics is really what? An easy and what? It's a simple subject. It's not a subject that should give you stress. You can see how they've gone. Thank you. I'll be expecting you in next video.